This is my demo video for project 2. First thing you want to do is you want to open the project root folder, and you'll see that I have 3 bat files corresponding to each of the programs which are used to run it. Or if you open the readme file, you'll see that if the alternative to running them is using the command in a terminal as shown for each program. To start, we'll run the wave compressor program. What this will ask you to do is choose a file. I'll select the first one here, and then it will compress the file using Huffman encoding after extracting each sample, and then it will output the result to a byte array, and then which consists of a byte for every 8 characters in the Huffman output, and a final byte representing the remaining characters that are less than 8. Once this is done, that will be stored as a conf.a file, and then the original output string will then get decoded and stored as a text file with every other value in the text file representing either a left or right channel sample. Right? And I'll be back when this is done. So as you can see, the WAV file was compressed and it's now 2.5 times smaller than the original. And if you go to the folder where the WAV file is, that's where the output's stored. You'll see that the compressed file here is smaller as well. I've also gone ahead and loaded 2 instances of the wave viewer. So the wave viewer, what you can do is when you open the file, you can choose either the sample data or the wave file, and it'll read it and display it. I'll just do this and this, and you can see that both of them are the exact same. Now I'm going to be back once each of the other files is loaded and compressed. Here are the results for the second file. You can see that it is significantly compressed. Its compression ratio is 2.2 times smaller, and both the outputs are the same after decoding compared to the original. And I'll be back again with the third file. And we're back. So the third file is compressed with a ratio of 2.0, which is 2 times the size of less than the original. As you can see here, it is roughly 2 times less. And also the outputs, as shown here, are both the same as well. Right. Next, what I'm going to do is show off the PNG viewer, or actually PNG compressor. So for that, what I did was I took the PNG file, input file, converted it to YCBCR, compressed it using fast DCT8 because originally my original 1D DCT on the rows and columns didn't work for some reason, and it couldn't display properly. And then that is then stored in as a byte array in a custom CLA3 file format. So if I open up, say, this one here, you can see that the results are here, and this compression ratio. Now the ratio is slightly not optimal for some of these files because of the fact that I could have done further compression. Also, you can ignore the console printout right now because that stuff is going to be removed on submission. And for some reason, either due to the fact that I'm still... Oh, also I forgot to mention, before storing to a byte array, I downsample the CBCR values. So it's a 420 downsampling. For some reason, either due to the downsampling or the way I'm reading and the stored values from the file to whichever type of array I'm using, there's these couple pixels that don't work, even after fixing the display issue by changing the DCT implementation. So let's just show you the other three, and then that'll be it too. And that'll be it. Uh, Four. That one's a little bit better for compression ratio. And balloons. Balloons is actually the one that's a little bit not as good, but that's probably just due to the fact of the way I'm explaining explaining things, and also the fact that I could have done a little bit more compression. And that's about it.